Welcome, week 2, June 29th to July 5th, new 12. We're going to be working on system substitution, and we are going to start where one of our equations is already solved for a variable. So one of the equations is set up for you. Let's start now. So again, just reviewing very quickly one of the things that's going to help us out, and you'll notice everything goes back to these very few concepts that we've already reviewed, but there's no harm in reviewing again. Substitution is one of those things. We find the ordered pair solution. So the y coordinate, when y is equal to 1/2 x plus 3, the y coordinate that corresponds to x equals 4. So just kind of creating that template. When we have y equals 1/2 parentheses plus 3, because they've given us x equals 4, okay? We want to find the y, and now I am plugging in for the x when x is equal to 4. So I'm taking the x out and plugging the 4 in. And again, you start to notice we're doing the same trends week after week, topic after topic, right? They give us x equals 4 and they've given us the equation. We plug the 4 into our equation. And when we do this, we get y equals 1/2 times 4 plus 3. I draw my line just to separate the left side from the right side. And I get y equals 1/2 times 4 plus 3. And I've just rewritten what I had. And 1/2 of 4, if you take half of 4 and I split 4 in half, I get 2. If we're using the trick from our live with fractions, we circle these two and we say, do they match? No, they're not the same. If they were the same, they would knock out. While they don't knock out, they're not the same number, but you do know that 4 does divide 2. Yes, 4 divided by 2 gives me 2. 2 times 1 gives me 2. So 2 plus 3 gives me 5. So y equals 5. So my ordered pair is 4, 5. Where did I get those numbers from? Well, the 4 came from here. The 5 came from what I just found, y equals 5. So the ordered pair solution we did get that 4, 5. Right now we've been doing this for 2 weeks, plugging in an x, getting a y. X's are always the in, what we put in. Y's is always what we get out, input, output. All right, so we are focusing this week on our 3 ways to solve systems. The first way we have is graphing. And the second way that we'll be doing today is substitution. The third way, I'm not going to give it away. We'll kind of just leave that blank. But there is a third way, which we will look at in a little bit. But we're going to focus on substitution this time around. So substitution looks at exactly what it sounds like, substituting something for something else. So let's get started by looking at number 2. In order to substitute, we need to have, something that's equal to something else. I can't substitute something that's not equal to something else. So, in the kitchen, we substitute, say herbs, rosemary for thyme, chicken for tofu. Some would argue that's not equal. Say, milk for cream. a fresh herb for a dry herb. This we are allowed to do. We're also allowed maybe, to do it when it's not one for one. We can change it a little bit, but we're going to focus on substituting things that may not look like they're equal, but they are. So when I have an equation that is solve for a variable, last week we focused on solving for y. Everything was about solving for y, solving for y, solving for y. And it's been really important to do that for slope-intercept form. And when we solved for y, it was all about y equals mx plus b. Get y alone. Solve for y. Now I'm telling you for systems, for the substitution method, you don't only have to solve for y, you just have to have something solved for a variable, meaning you have to have x alone or you have to have y alone. And since you have two equations, it only has to happen in one of your equations. So we look at number 2, and this is not solved for the variable. This is solved for the variable. I want to say, I'm sorry, there's only, it's solved for the x, right? If we look at this, the 5x here, the 2y here, the x, and the 3y, the only one that is, isolated or by itself is this x here. So that's the only variable that is isolated, that is solved for itself. That is the one that I want to use. So what that means is in the other equation, that is the one I am taking out. That's the one I'm substituting for. So it's a little bit strange. You want to find the one or isolate one, but then in the other equation, I want to take it out. So isolate a variable, and then in the other equation, take it out. So because I've isolated x in the second equation, in the first equation, I'm going to take x out. And that means I'm going to write my first equation, as a template. Like that. Okay, so now I wrote my first equation as a template with the x out. And because I took the x out, I want to put what x was equal to in. So I'm going to put this in for my x. Now, I didn't really leave myself a lot of room, but I'm going to try to fit it in there. And I'm going to write 3y plus 1. Okay? When I go and I look at this, now I've eliminated my x here by substituting x, the other side of the x in, and now I have all y's. So I'm going to distribute this. I'm going to get 15y plus 5 plus 2y equals 22. And I'm going to go ahead and solve this. I'm going to combine my like terms. I'm going to get 17y plus 5 equals 22. And subtract 5 from both sides. And I get y equals 1. I'm going to plug it back into my other equation. Plug it into my ordered pair, and my ordered pair is 4, comma 1. And I'm all done. Let's go to the next one. I look at all my variables and I have x, I have negative 2y, I have negative x, and I have 3y. The only one that is isolated and positive is this x in my first equation. So that's the one that's solved. So that's the one I want to use. Which means that in my second equation, I want to get rid of x, which means I'm going to rewrite my second equation with my x removed. So this is going in there. I do need to keep the negative in that second equation. I can't get rid of that. So I need to plug in the 7 minus 2y into that parenthesis. Now, when I distribute the negative, I get negative 7 plus 2y, and then plus 3y equals 3. Combine my like terms, I get negative 7 plus 5y equals 3. And I go ahead and I keep solving. I get my y to be 2, and then I go ahead and I keep plugging in. And I get x to be equal to 3, which makes my ordered pair 3, 2. And I'm all done. Looking at number 4, I'm looking for my isolated variable. I find it in my first equation for x, which means I'm taking this 7 plus 2y and I'm putting into the x in my second equation. So I'm rewriting the second equation without my x, but with everything else intact. And I'm rewriting that 7 plus 2y in where that x used to be. I'm distributing, so I get negative 35 minus 10y plus 4y equals negative 5. I'm going to go ahead, combine my like terms, and I keep solving. I got negative 5 for my y. I plug it back into either equation works, but I'm going to plug it into the first one. I got x to be negative 3, so my ordered pair answer is negative 3, negative 5. And I'm all done. I will see you soon. Make sure you ask any questions that you have and let me know how it goes.